So while surfing, I'm always trying to find ways to increase my velocity and acceleration, whether it's to prepare for an upcoming maneuver or to just get to a place on the wave where I really feel I need to get to. Uh, and that being said, I was wondering if there's any empirical evidence within the peer review process which helps me to answer this question whether or not I should bottom turn or highline when I'm trying to generate maximum acceleration. And while I was at UCSD, I remember there was this talented surfer and physicist named Nick Pizzo who published a paper about acceleration and velocity. At the time, I didn't read the paper, so I revisited the literature and I was able to find Nick Pizzo's 2017 paper titled Surfing Surface Gravity Waves, published in the Journal of Fluid Mechanics. And what Nick was able to do was use John's equation to develop a criteria that describes how particles or humans surf.
Bruh.
And what Nick's criteria states is that if a particle on the forward face of a breaking wave approaches phase velocity and experiences horizontal velocity as a result of the underlying wave, that particle is said to be surfing.
Well done.
Which is important because it lays the groundwork for us to understand how particles interact with breaking waves for us to identify where on that wave possesses the maximum potential for acceleration. And by looking at the motion, velocity, and acceleration of water molecules across breaking waves, Nick was able to identify that molecules on the upper region of the forward face of a breaking wave just under the crest possess the highest values for both velocity and acceleration. So comparatively, a high line in the upper region of a breaking wave just below the crest provides more opportunity for acceleration when compared to, say, a bottom turn where you go out of that sweet spot region. What's super cool to me about this paper is that water molecules just below the crest of a simulated wave start out with an acceleration of less than half a g, and that dramatically increases to an acceleration about 4 times the force of gravity, which infers that a surfer can experience an extreme increase in acceleration if a highline is initiated just after takeoff and extended out through the ride. Things to keep in mind while looking at the data: these are theoretical predictions and numerical simulations. Additionally, deep water perturbed Stokes waves were considered in this investigation, which don't take into account depth or bathymetry, although Nick does state that deep water perturbed Stokes waves possess similar characteristics in both deep water and shallow water breaking waves.